Hi. Okay, it looks like I already started this because I already did. Having some technical difficulties, but whatever. We're going to do this again. So in this one, we're going to do daily lessons 185 and 186. Woo woo, calculus. Let's do this thing. So you can tell my graph is already drawn a little bit. Sorry about that. I already did this video partially. Yeah. Let's try it again. In here, it says f of x is defined to be this function. So we have f of x is defined as an integral. Over here, this graph is g of t. G of t is not labeled to begin with, but make sure that you do that. So g of t. In this first one, it asks for the function value at 0. So I can't just go over here and say, oh, well, I'm going to find the function value at 0, and that's 3, because this is a graph of g of t. So what I need to do, if f of 0 is defined as this integral, anywhere I see an x, I'm going to substitute in 0 instead. So 2 times 0 would be 0, g of t dt. And then I think, how could I possibly solve this? Well, I could do the fundamental theorem of calculus if I have an antiderivative. So what's the antiderivative of g of t? It would be like capital G of t. Do I have this anywhere? No. So I can't do capital G of 0 minus capital G of -4 or some antiderivative because I don't have the antiderivative. What I do have is this graph. And so I can say that lowercase g of t, they match. As soon as that happens, an integral means the area under the curve of g of t from -4 to 0. And so what I need to do is find this area. So when you're drawing this, the way that you do it is you make a horizontal line on the x-axis. So I would do this down here. I did it once, but I'll do it again. Sorry, squeaky chair. From -4 the whole way to 0. On the left-hand side, I'm going to come down until I hit my graph because there's no place to go up. On the right, you're going to go up. So you hit your graph. And then you're trying to find this area of this region down here and this one up here. These two areas right here, this area below the x-axis and above, are the same and they will cancel out. This area is just a rectangle. And so I can see I'm breaking this into two parts, a rectangle and a quarter of a circle. In this rectangle, I can see I've got a base of 2 and a height of 1. So you can say 2 times 1 plus a quarter of a circle. How do you find the area of a circle? Pi r squared. This is a quarter of it. Oh, I should say the radius in this case is 2. And then it's like magic because I already did it before. And the next one, you try this one. What is f of 2? Do the same thing that I just did. Did you take the area that you got the first time and you doubled it? Because I'm going from the whole way from -4 to 4. Or you could have added up each individual part and you still should have gotten 4 plus 2 pi. Okay, in the next one it says f prime of 1. Before you can actually find f prime of 1, let's find f prime of x. So actually over here, if f of x is equal to this integral, -4 to 2x of g of t dt. So if I'm finding f prime of x, I have to think about what is the derivative of an integral. The derivative of an integral is the stuff on the inside. It's like multiplication and division or addition and subtraction. They're inverses one another. They cancel out in so many ways, but it's just a little bit more complicated because if I take the derivative of this integral, I get the stuff on the inside, but I also have to account for I'm putting a function. I'm not just substituting in x here, which x actually is a function in itself with just a derivative of 1, but I'm substituting 2x. So the chain rule applies. Wow, times 2. Commonly missed on tests. Don't let it be you. Don't volunteer as tribute. If you want to find f prime of 1 then, I'd say g of 2 times 2. And this is actually right where it cut out before in a video. So I have g of 2 times 2. G of 2, g is the graph, so I'm going to go g of 2, and I find this value at 1. So you get 2. In this one, it says find the value of f prime of 3. F prime of 3, we can use what we found before, and we know f prime of x, it's g of 2x times 2. So this is going to be, oh wait, you know what? It's going to be off your graph if you do that. Change this one to f prime of 1.5. Okay, so I have a correction for numbers 4 and 5. In both of them, instead of f prime of 3 and f double prime of 3, change it to f prime of 1.5 and f double prime of 1.5. So you're finding f prime of 1.5, no longer of 3. Oh, that's terrible. There we go. Okay, before I can find f prime of 1.5, I want to find just what f prime of x is, remember? So we did this already, g of 2x times 2, so this will be g of 2 times 1.5 is 3 times 2. G of 3 is 0 times 2 is still 0. F double prime, if I know f prime of x is, and I'm going to just write that as in front sometimes, g of 2x. Use what you know about derivatives. You need the chain rule, by the way. What is the derivative of 2 times g of 2x? Wow. 2 stays along for the red. Derivative of the outside would be g prime. Leave the inside alone. Times derivative of the inside, which is just 2. If you would have just said, well, isn't this the product rule, and did the product rule, you would end up getting the derivative of 2 is 0. So that's why we don't have to do it. Coefficients can just come along for the ride. They can just be carried down. So that means f double prime of x is 4 g prime of 2x. So if I want to find f double prime of 1.5 for g prime, 2 times 1.5 is 3. Okay, how do I find g prime of 3 if all I'm given is the graph of g of t? G prime is the derivative, also known as slope of the tangent. So at 3, what is the slope? Well, I can see I go down 1, right 1, down 1, right 1 on my slope. That means my slope is negative 1 over 1, or just negative 1. This would be 4 times negative 1, or negative 4. Okay. Any questions on this stuff? Going on to the next one, this one just says find the derivative of each of these following functions. So we're trying to find what is the derivative of f of x. Remember that a derivative of the integral is like you take the integral away and it's the stuff on the inside. But we have to be really careful because we're substituting whatever this upper limit of integration is. This is the fundamental theorem of calculus, the other part of it, not the f of b minus f of a, but if we find the derivative of the integral, it's the stuff on the inside with this substituted. But you have to remember, whatever this is a function in itself, so you have to take the derivative of that because of the chain rule. So here, I'm going to say 2 minus something squared. What the something is I'm substituting in 2x times the derivative of the inside. The inside is just whatever this upper limit of integration is. The derivative of 2x is just 2. Let's simplify just a little bit, only because I've seen people do this wrong. If you take 2x, this quantity squared, square both parts. 2 squared is 4. X squared. I still have this times 2. I'm going to write it on the outside. And then I would just leave it like that. Okay, the next part. You might be thinking, wait a minute, this one doesn't look like this one, because this has x squared to negative 3. You're right, it doesn't look the same. This, whatever this function is, this x squared, this has to be the upper limit of integration, or else this won't work. Think about when we did this by hand and we did the antiderivative and then did f of b minus f of a and then found the derivative. It was really important this was first, where it would mess with the sign, because we're taking capital F of b minus capital F of A, it would mess with the sign. So this needs to be the upper limit of integration. So how I do that is I switch it. And then I just make this integral negative. And just like with derivatives, when we took the derivative here, we could bring, or where was it? Yeah, here, where we can bring this 2 along for the ride, like it just becomes part of the derivative. The antiderivative, same thing. I can do that again. Well, actually I'm taking the derivative anyway, so it doesn't matter, but the for the derivative, it just comes along for the ride. So g prime of x, whatever my answer is going to be negative. And now I can do the rest. So negative, I'm going to put this in parentheses just so I remember to multiply by a negative. Okay, the derivative of any integral is the stuff on the inside. So e cosine, but instead of this variable of t, I'm going to substitute in x squared times the derivative of the inside. That's just this thing, whatever this function is. The derivative of x squared is 2x. And then leave it like that. In this last one, if I take the derivative, it looks scary. Remember, the derivative of an integral is the stuff on the inside, but just make sure to account for the chain rule. Wow, you try it. Did you substitute in cosine of x instead of t squared times the derivative of the, whatever the upper limit of integration was, the derivative of cosine being negative sine. And then I would leave my answer like that. That's it. Were you really hoping we do one more page though? Like one more? Were you thinking, we did a graph, we've worked with equations, can we please, please, please work with the table? You got it. I like to be predictable. And here we've got this, and this actually brings together a couple worlds because we've got an equation, we've got a table, and we've got a graph. What could be better? And here we've got let f of x, capital F of x, equal this function where f of t is shown to the right. So here we've got f of t. If we need to complete the following table, what we would be doing is we would say capital F of x, 3, so I'm using this up here. Anywhere I see an x, I'm going to substitute in whatever value I'm looking for. So like this was f of 2, so I'm putting 2 in for x. And I'm hoping you're thinking, oh, this is wrong. The lower limit of integration should always be on the bottom. This should always be a lower number down here. Let's make this negative. So my answer is going to be negative, whatever my answer is over here. If I think about how can I do this, how can I find what this value is, I can see the graph I have and this integral, the stuff inside the integral, match. So I can do the area under the curve. So I'm going to go from 2 to 3, so right here. And if I try to find what this area is, I'm going to go down until I reach my my function. At 3, I'm going to go down until I reach my function. I find the area of that region. This is just a trapezoid. So I'm going to say 1/2. Base 1 plus base 2, I can see here this was, you can write -4, or you can say, you know what, I know this whole thing is below the x-axis, so I'm going to just make this whole thing negative. This would be a height of -4, this would be height of -6, but I already accounted for the negative, so I'm going to just say 4 plus 6. The height, remember, is perpendicular to the bases that are parallel. So here, this has a length of 1 or a height of 1, and that's it. 4 plus 6 is 10, times 1 is 10, times that half is 5. Negative and negative cancel out, you should just get 5. If I do the next one, by the way, that first one should have been f of 2, I should have written over here. If I want to find f of 3, this one's fast. 3 to 3. Anything, there's no region there. 3 to 3 would just be 0. Okay, here's what you can do. You can skip to the next part in the video, or you can follow along, and because I'm going to fill these tables or the values in this table in. If you want to practice them, this would be a good time to do so. If you want to know, like, what is the area under the curve, and you know that you need some work on that, practice that now. But if you find f of 5, you should get -6. This one's weird a little bit. This is -4.5 or -9/2. This one's 12. Okay, so if you need to practice those now, do that. I'm going to show you just my work below. If not, skip ahead. To find f of 5, I'm on this interval from 3 to 5. So 3 to 5 would just be this triangle. I know it's negative because it's below the x-axis, so -1/2. Base here is 2. Height is 6. And you would have to write this as -6 if you didn't already make it negative here. This is where -6 is coming from. To find capital F of 6, in this one I would be saying 3 to 6. And we already did 3 to 5, so you can use this -6 plus this little bit extra, which would be 1/2. 1 times 3. That's where the -4.5 is coming from. If I did f of 9, going 3 to 9. Well, I know to 6, this whole way would be -4.5, plus I keep going the entire way to 9, and I would break this into 2 shapes. I would do this trapezoid, so 1/2. Base 1 and base 2 would be 3 and 6. My height of my trapezoid is the stuff laying down. It's parallel to the bases, or I'm sorry, perpendicular to the bases. The bases are always parallel, so this would be 1. Plus, I've got this rectangle. It's a 2 by 6. Here, if you do this -4.5, and here we'll cancel out with 4.5, and you get 12. And you could have seen that too. I just didn't recognize it quickly enough when I was doing this. Okay, we're all back together now. In this one, on what intervals is f of t positive? Okay, this one seems like a trick question. It's not. Where's the graph of f of t positive? Above the x-axis is positive, below is negative. So here, this is going to be on the interval from 5 to 10. And you might say, parentheses are not at 5. This f of t is 0. Over here, it's still positive, so I can say 10 is included in that. On the interval. There you go. F of t is negative. You tell me. Yeah. 0 to 5. So on this interval from 0 to 5. Okay, then the next one says, on what interval is f of x increasing? So before you even look, because this is capital F of x, I want to write down capital F of x is increasing when we know a function is increasing when what happens? When its derivative is positive. And so what I want to know, what is f prime of x, capital F prime of x? So if I go back up to this function, capital F of x is defined by this integral. The derivative of the integral is the stuff on the inside with whatever that upper limit of integration is substituted. F of x. And this seems kind of crazy because now I'm going back with x's and t's, and that's okay. Sometimes these graphs will just be labeled as f instead of f of t or f of x. I know it's crazy, but that's what happens. So if I want to know f prime of x is positive, and I know f prime of x is equal to f of x, we know f of t is positive, which in this case now turned into f of x, on the interval from 5 to 10. So I'm going to say on interval from 5 to 10. And my reasoning as capital F prime of x is equal to f of x. Okay, so you do this one. What do you think? Did you get f of x is decreasing when f prime of x is negative? And this is on the interval from 0 to 5. And you have to make sure to say, even though we said in the last one, capital F prime of x is equal to f of x. If I want to know when f of x is concave up, so write this reasoning down. Capital F of x is concave up when, so even if you didn't have any graphs, any tables, any integrals here, capital F of x is concave up when f double prime is positive. Okay, and then I think, well, I know capital F prime of x is equal to f of x. I just said that up there. But I don't actually know if I have f double prime, f prime is equal to f of x. All I've got is f prime. So what would be happening to capital F prime? Because that's the only thing that I know since I have f of x. So f of x is concave up when f double prime is positive. Therefore, f prime, think about this, if the slope of f double prime, or I'm sorry, if f double prime is positive, so this is the slope of f prime is positive, that means f prime is increasing. And we said these were equal, so it doesn't matter which one we use. I'm going to say f of x is increasing on the interval. Okay, you look. When is f of x increasing, lowercase f of x? From here to here, which would be, I've written a lot on this, 3 to 7. And that's enough. We don't have to go back and say, therefore, f of x is concave up. We said all of it already. Okay, try this one. Check your work with mine. F of x is concave down when f double prime is negative or less than 0. Therefore, f prime is decreasing. F prime is fine. F prime of x is fine, whatever you want. Capital F prime of x is equal to f of x. Be really careful about writing capital or lower cases there. F of x is decreasing. Lowercase f of x is decreasing on the interval from 0 to 3. That's it. Let me know how you did, what you need, and how we can help you know this better. Thanks so much for being great. I appreciate you. Thanks for learning. Bye.